Hello everyone and welcome to the ninth topic in the SS1 Physics curriculum for first term. Now, in the previous video, we discussed the concept of work, energy and power, and the topic is a broad one, so it spreads into this one now. And this time what we'll be looking at is problems on work, energy and power. Now, this is a major aspect in your journey as a physicist. You should be able to calculate work done, the amount of work done, the amount of energy transferred or transformed, and also the power expended during such process. Now, all of these gives us different types of problems that range from all the different forms of energy that we have, and we'll be looking at different kind of questions like this, from the ones that are set by professionals into the ones that are done in professional exams like the WASI exams, the UTME exams, the SAT exams, amongst others like that. We're going to look at different kinds of questions, and I'll be showing you some tips that will help you know what to do when you find questions that looks like the ones that we are solving. Kind of like what you should know, the basic foundation that will help you solve problems like that and take you through the process and ensure that you understand how to calculate work done, energy and power. Now, if you're seeing this video for the first time, welcome to our channel where we give you educational content all the time. So you don't want to miss our videos. Please check it out. We've been doing a lot of work here and we'd like you to check our videos out and leave us a comment if there's anything you would like us to touch next. And also please ensure that you're subscribed to the channel. It's only going to take a moment of your time. All you have to do is click the subscribe button, and then you can also hit the notification bell icon so that every time we put out a new content, you will be notified. And we beg you to also help us by sharing this video. Now, what we want to do is to reach many students that are in need of content like this, and you just might have them on your list. So please help us by sharing the video so that they too can know of the amazing work that we are doing here on this channel. So please like, share and subscribe. And if there's anything at all you'd like us to discuss, we're waiting on your comments. Put it in the comment section and we'll definitely attend to all your comments. Now, I believe you're ready. Get out all your materials and let's solve some problems on work, energy and power. This question says, a boy of mass 50 kilograms climbs a wall 2 meters high, and we're to find the work done by the boy. Now, when you have to solve a question like this, now, first thing you have to do is pick out the parameters you can see in the question and what you're asked to solve for. Now, solution. In the question, we can clearly see that the mass of the boy is 50 kilograms. And we can see that the distance, that is displacement here, which is a vertical height, is 2 meters. And we are asked to calculate the work done. Now, in this kind of case, work done is supposed to be weight times displacement, or force times displacement as we know it. So we say the work done equals mg, which is the weight of the boy, then the displacement, which is h, so mgh. And I mentioned in one of our videos that the questions can either give you a particular value of gravitational acceleration, or if it is not given, you use the approximate value, which is 9.87 meter per second square. So we're going to take g to be 9.87 meter per second square. Now let's find work done. Work done is therefore 50 kilograms multiplied by g, which is 9.87 meters per second squared, and then we multiply that by height, which is 2 meters. Now this is quite easy to solve. All we need to do is just know that all of this comes to joules. So 50 times 2 will give you 100, and 100 multiplied by 9.87 will give you 987 joules. So the solution to this question is 987 joules. In this question, we are asked to find the kinetic energy of an object of mass 20 kilograms moving at a constant velocity of 15 meters per second. Now, to solve this solution, what do we have? We're given that mass is 20 kilograms. Now, we're also given that the velocity is 15 meters per second. And to find kinetic energy, you recall that the equation says kinetic energy equals half mv squared. So all we have to do is put in these parameters at the appropriate point and then apply the equation. So the kinetic energy, therefore, would be 1 over 2 multiplied by mass. Now the mass is 20 kilograms multiplied by a square of the velocity. That would be 15 meters per second all squared. Now let's tidy this up. 2 here 1, 2 here 10. So kinetic energy becomes 10 multiplied by, now 15 squared would give us 225. Now all of this, kilogram meter square per second square, would give you joules, right? So kinetic energy of this object is therefore 10 multiplied by 225, which will give you 2250 joules. Now if you like, you can write this in multipliers by saying this is something like saying 2.25 times 10 raised to power 3 joules, or basically we just say kinetic energy equals 2.25 kilojoules. Now all of these still mean the same thing, which is 2250 joules. In this question, we see that a stone of mass 0.5 kilograms was released from the top of a tower. Now, we are asked to find the velocity of the stone after falling a height of 45 meters. We are asked to take gravitational acceleration as 10 meters per second squared. Now, in this question, we are finding velocity. And the equation where you can find velocity is in kinetic energy. And since the object is falling, it means it has kinetic energy. But you cannot get this directly without equating it with the potential energy when the object has not started moving, or basically the work that is done for it to fall from the height it is initially to that point when it is 45 meters down, right? So to do this is how we solve it. We're going to equate two equations here, mgh being the work done, and then we equate that with the kinetic energy after it has fallen for 45 meters, which is half mv squared. Now, when you look at these two equations, we see that they both possess m, so they can cancel out, leaving us with gh equals half v squared. So linearizing this, you have v squared equals 2gh, and then v becomes the square root of 2gh. So all we need to do is apply this. Now let me go over this again so you don't get confused. This is the work done here, mgh, equated to the kinetic energy of the object. Since it's falling, half mv squared. Now m here cancels m, that is why we have gh equals half v squared. And then when you cross multiply here, 2 comes here and multiplies by this to give you 2gh, and this remains v squared. Now, whenever you want to resolve this part, you have to find square root of both sides. So the square root of this gave us v, while the square root of this remains square root of 2gh. So the velocity is therefore the square root of 2 multiplied by gravitational acceleration. Now, it is a constant, but in this question, we are given to use 10 meters per second squared. So that will be 10 meters per second squared, then multiplied by the height that's falling, which is 45 meters. Now take a look at this. V therefore becomes square root of, now 10 times 45 is 450 times 2, and then we have 900. Meter times meter, that's meter squared, and then we have per second squared. So let's find the square root. The square root of 900 would give you 30. The square root of meter squared is meter. The square root of per second square is per second. So we see that is in the correct SI unit for velocity. So the velocity of this object after falling for 45 meters is 30 meters per second. And that's the solution to this question. In this question, we see a man of mass 50 kilograms ascend a flight of stairs that is 5 meters high in 5 seconds. And given that gravitational acceleration is 10 meters per second squared, we are to find the power expended. Now here's how you solve a question like this. Now, power equals work done over time, right? So, and the work done here is given as mgh, and then time remains t. So what will be the power then? The mass of the man is 50 kilograms multiplied by gravitational acceleration 10 meters per second squared multiplied by the height, which is 5 meters. Now all divided by the time, which is 5 seconds. Now what you see here, 5 cancels 5, and then you see the power is 50 times 10, that gives you 500. And meter per second, kilogram meter per second times meter will give you joules, right? Per second, because we still have seconds down here. So power here is 500 joules per second. However, there's another name given to joules per second, which is known as watt. So this would be 500 watts. And that's the solution to this question. Questions like this can be a little bit tricky for students who expect a specific kind of parameter to solve for power. Now, this question tells you about a car moving at a constant speed of 20 meters per second, and that the force retarding the motion of the car is 500 newtons. And then you're asked to calculate the engine power of the car required to maintain the motion. Now, one easy way you can use to solve questions like this that do not have the usual parameters is to use dimensional analysis. Now, what we're trying to find is power. And power is measured in watts, which is basically joules per second or Newton meter per second. Now, note this. Watt is joules per second, right? While Newton meter equals joules. Okay? Now, joules itself is Newton meter because force times displacement. And to get power, we just need to add per second to that. Now, look at what we have here. We already have Newton here. And this is meter per second. So that is watt is basically joules, which is Newton meter, then per second. So, and this relationship here is a multiplication, right? So to solve this, all we need to do is say the power of the engine is therefore the retarding force, which is 500 newtons, multiplied by the velocity. And that velocity is 20 meters per second. This is how we can get Newton meter per second, which is equivalent to watt. So the power of the engine is therefore, now 500 times 20 would give you 10,000 joules. So, and this is the solution to this question. Before we go on and solve this question, if you're yet to be subscribed to the channel, please take a moment of your time and click the subscribe button. And also hit the notification bell icon so that you get alerted every time we put out a new content. And please help us to reach many others who need content like this by sharing the video so that they get to see it and then follow the link to our page. Thank you so much. And don't forget, if you have any question on what we are doing so far, or if you have a question of your own on this topic that you would like us to solve, kindly put it in the comment section and we'll definitely attend to all of your comments. Now to the question. This says, at what height above ground must a body of mass 10 kilograms be situated in order to have a potential energy equal in value to the kinetic energy possessed by another body of mass 10 kilogram moving in with a velocity of 10 meters per second. Now this is an SSC question, and it has a hint where we are told that gravitational acceleration is 10 meters per second squared. Now to solve this, you can then equate the potential energy of the body to the kinetic energy of the other one. So, and potential energy, recall potential energy is mgh, and then kinetic energy is half mv squared. Now when we equate them, we say mgh equals half mv squared. Here you see m cancel m, and when 2 comes here, you have 2gh equals v squared. And what we are asked to find is the height above ground. So we make that the subject. So h becomes v squared over 2g. Now let's apply that. Now the height above ground would therefore be the square of the velocity. Now the velocity is 10 meters per second squared, so that's 10 squared divided by 2 multiplied by g, which is 10, and this would give you 100 divided by 20. And since it's in meters, this is going to give us 5 meters. So the object has to be 5 meters above ground for it to have the same potential energy as the other object that is moving at 10 meters per second. That's the solution to the question. Now you recall that in the previous videos we've done, I mentioned at some point that energy is not limited to just mechanical alone, that you could also have it in electrical, in solar, and other forms like that. And the same thing applies to power. You can also get them in all the forms of energy that you have. Now, this is a question that stems from that. This says we are to find the electrical energy expended by a 100-watt bulb in 8 seconds. Now, here's the solution to that. Now, we know power equals work done or energy expended over time, right? So the power here, now the power is already given as 100 watts equals, now the energy expended is what we are asked to find, so let's just write that as E, divided by the time taken, which is 8 seconds. Now energy therefore becomes 100 watts multiplied by 8 seconds. That will give you 800. Now watts and seconds combine to give you joules. So the energy expended in 8 seconds is 800 joules. And that's the solution to the question. Let us kill 2 birds with 1 stone using this question. Now in this question, we're asked to calculate the work put into a machine which lifts an object of mass 100 kg 25 meters high if the machine is 80% efficient. Now in this case, we just equate efficiency of the machine to work output over work input. And another thing we can do to a question like this is sometimes the question may be twisted and then you're asked to find the energy wasted, right? So we just do both so that you learn how to do whether you have to find the work input, work output, or energy wasted. And this is how we do that. Solution. We're applying that efficiency equals work output divided by the work input. And you should know that work is mgh in this case. So the efficiency is 80%, so 80 over 100 divided by work input, which is mgh. M is 100, g is 10, times h, which is 25, according to the question, right? Divided by work input. So now we can just solve for work input directly by saying work input equals, Now this remains the numerator in this case. So we see we have 100 multiplied by 10 multiplied by 25 in this case. And this numerator will give you 25,000. Now divided by, now when you resolve this you get 0.8. So you are dividing by 0.8 here. Now you can then divide and this will give you 31,250 joules. This is the work put into the machine. So you can imagine this is the amount of work that is put into the machine, but in the end the useful work that is done by the machine is 25,000 joules. That tells you that some energy is wasted. So if you're asked to find energy wasted, now this energy that is wasted may be used to conquer friction amongst other things that actually reduce the efficiency of a machine. So the energy wasted is actually work input minus work output. Now that means we have 31,250 joules minus 25,000 joules. And the difference is 6,250 joules. So whichever one you're asked to solve, they all follow the same process. You have to find the work input first before you can then be able to find the energy wasted. So this is the solution to this question. If you have any question at all on the process, or if there's any other question you have in mind concerning work, energy and power like this, please put it in the comment section and we'll definitely attend to all your questions. This question says, if a pump is capable of lifting 5,000 kilograms of water through a vertical height of 60 meters in 15 minutes, the power of the pump is, that is basically we have to calculate the power of the pump, or the power in the pump, of the pump. That's what the question says, the power of the pump. Now, to solve questions like this, it's quite easy. We just have to apply MGH over time. Now, if you're yet to be subscribed to the channel, kindly do so by clicking the subscribe button and the notification bell icon so that you get alerted every time we put out a new content. Now, if you have done so, now I would like you to take a pause on the video and try to solve this question yourself first, and then you can compare your answer with what is gotten at the end of the video. So now that you've solved it, let's compare with this. Now, in this case, the power of the pump is mgh over T. Now, there's just one thing you need to put into consideration when solving. The time given here is minutes, meaning you have to convert that to seconds. Now, I hope you did that while you were solving, but if you didn't, just observe how it is done. Now, the mass that is lifted is 5,000 kilograms. So we multiply that by gravitational acceleration, 10 meters per second squared, should be squared. Then we multiply that by the vertical height it goes through, and that is given in the question as 60 meters. All divided by the time taken, which is 15 minutes. So 15 times 60 to bring it to seconds. Now let's see what this gives us. That is power equals, now 5,000 times 10 times 60. All divided by 15 times 60. All of this in watts. Okay? Now we see 60 goes in 16 here, 5 here, 3, 5 here, 2. Now what this gives you is 5,000 times 2, that's 10,000 watts divided by 3. And when you divide here, you're going to get 3,333.33 recurring like this. So, and this is in watts. Now, this is a UTME question, which means you're going to have a variety of options to pick from. Now, all you have to look for is the options that is closest in value to this, or that is written as a multiplier of this. Meaning you could find options where you have something like 3.33 kilowatts. This is also the same as what we have here. It's just with the multiplier kilo, which is times 10 to the power of 3. I hope you understand what that means. But anyways, the answer to this question is 3,333.33 watts. This question says, if a load of 10 newtons stretches the cord by 1.2 centimeters, what is the total work done? Now you see that in this case, the load applies its own weight as the force as 10 newtons, and it causes the point at which it applies that weight to move by a distance of 1.2 centimeters. However, this 1.2 centimeters is not in the SI unit, so meaning we have to convert this into the proper SI unit, which is in meters. Then we solve by doing force times displacement. So here's the solution. We see that the force is 10 newtons, 10 newtons according to the question, and the displacement is 1.2 centimeters, which is 1.2 divided by 100. That is basically 1.2 times 10 to the power of negative 2 meters. Now let's apply this. The work done is force times displacement, so 10 newtons multiplied by displacement, which is 1.2 times 10 raised to the power minus 2. This is in meters, so we have that in Newton meters. Work done is therefore 10 times 1.2 will give you 12. So 12 times 10 raised to the power minus 2 Newton meter, or we say 12 times 10 raised to the power minus 2 joules. Now there are a lot of ways this can be left, because it's a UTME exams, which means you have options. So you just have to look for the one that is exactly 1.2 times 10 raised to the power minus 2. Or if we're going to put it in normal form, we'll say the work done in this case will then be 0.12 joules. So this will be it in normal form. So any of these is correct. All you have to look for is the option that gives you any of these ones that we've solved it to be. Let's solve this 2008 UTME question where we're told that the generator is on daily use, and in the process 10 60 watt and 5 40 watt tungsten bulbs are on for the same time interval. Now we have to find the energy consumed daily. Now here's a hint for you. Whenever you're solving electrical energy, it is often left in kilowatt hour. Okay, so electrical energy is in kilowatt hour. And then the next thing you need to also look at before you can then solve this is the relationship between energy and power. Now that you already know from the equation from power. You know that power itself is supposed to be work done or energy consumed over time taken. So it means energy itself is power times time. Now this is what we're going to apply to solve the question itself. But don't forget, it is in kilowatt hour. Now what kilo means is that whatever energy you have divided by 1000, whatever power rather you have divided by 1000 to convert it into kilowatts. Okay, so here's the solution. The first thing we want to do is the total power. The total power expended. And that will be, now we have 10 60 watt bulb, so that's 10 times 60 watts plus 5 40 watt bulb, 5 times 40 watts. Now all of these comes to, this is 600 watts plus, this would give you 200 watts. That is, together we have 800 watts. Now we have to bring this to kilowatt, so total power is therefore 800 watts divided by 1000 watts, or multiplied by 1 kilowatt. So the watts cancelled watt here, And then our answer is 0.8 kilowatt. Now the time is 1 day, which we have to live in hours, and that is what? 24 hours. So the energy consumed daily is therefore the total power, which is 0.8 kilowatts multiplied by 24 hours. And when you multiply this, you get 19.2 kilowatt hour. And that's the solution to this question. This 2022 UTME question says, a train of mass 1,600 kilograms attains a speed of 25 meters per second in 20 seconds. Now, we have to calculate the energy developed in the engine of the train. Now, in order to solve this, there are some things we need to do. We need to first find the energy of the train. And since the train is moving, it means it has kinetic energy. So the energy is half mv squared. So that will be 1/2 times the mass 1,600 times velocity squared. That's 25 squared. Now what this gives us is 1/2 times 1,600 times 25 squared is going to give us 5 times 5 is 25, 5 carry the 2, this is 10, that gives you 12, and this is 10, 0 carry the 1, 2 times 2 is 4 plus 1, and we have 5. Now let's add, this is 5, this is 2, this is 6, so we have 625 here. Now 2 goes here once, 2 goes here 800. So our energy is 800 multiplied by 625. Let's do that. 625. Now this is 0, 0, this is 40, this is 0, 0, and this is 16, and this is 0, 0, and this would give us 48. Now let me divide. So this is 48. So we have 0, 0, 0, 0, 0. So we have 500,000 joules. So now that we have the energy, we can find power. Power is energy over time. So 500,000 joules divided by the time is 20 seconds. And this will give us, now 0 cancels 0. 2 here 1, 2 in 50 will give you 25. Now all of this, that's 0, 0, 0. So 25,000 watts, or we just say 25 kilowatts. So the answer to this question is either 25,000 watts, or we just say 25 kilowatts. This question from the 2024 UTME asks that we pick from the options the one under which work is done. So that is under which condition is work done, basically. And then we have 4 options to pick from. The first one says a man supports a heavy load on his head with his hands. The second says a woman holds a pot of water. The third one says a boy climbs onto a table. And then D, a man pushes against a stationary petrol tanker. Now, many times we use work done and energy interchangeably. Now, in all 4 of these options, we see that energy is expended. But in which of them is the energy expended leading to work being done? Now, for work to be done, that energy must apply a force that moves an object from a position to a new point. So that is, there has to be a displacement for work to be done. There has to be displacement. So in this case here, we see that from option A, the heavy load remains on his head. There is no displacement. So work is not done even though energy is expended. In option B, the woman holding a pot of water, the water does not change position, neither does the woman. According to the option, we are not told that. So that means that even though energy is expended, work is not done because there is no displacement. And then to the third option, we see a boy that climbs onto a table. Now, for him to climb onto a table, it means he was standing initially and then he went up on the table. You see, there is a displacement. So because energy is expended and there is a displacement, it means work is done. And then option D says a man pushes against a stationary petrol tanker. Now, no matter how strong the man may be, he should not be, I don't think he's able to single-handedly push a petrol tanker. Now, even if he is able to do that single-handedly, this option does not tell us that the petrol tanker moves. So unless it said he pushes it and then he moves a certain distance, we cannot tell if work is done directly here. So since none of that is mentioned, we just assume that the petrol tanker does not move and hence work is not done. So the only option where there is a displacement is option C. Therefore, the only one where work is done is when the boy climbs onto the table. So if you are faced with a question like this, the correct answer is option C. This 2013 question is quite technical. Here we see a gas at a certain pressure of 10 to the power of 5 Newton per meter squared, and it expands from 0.6 meter cube to 1.2 meter cubed at constant temperature, and then we are asked to find the work done. Now, because as SS1 students we are not yet introduced to pressure and all of this, there's one way you can always find out how to solve a question like this, and that is by dimensional analysis. So you don't have to wait until you get to those topics before you can practice for your UTME exams and even other exams like that. With your knowledge on dimensional analysis, you can be able to derive an equation that will work for you with questions like this. Now, one thing I want you to know is this. Pressure itself is force per area, right? This we have already done when we were studying dimensional analysis in this first term as well. And then we have volume, which is in meter cubed, right? Volume. Now, the way you can put all of this together is this. See, force itself is in newtons over area, which is in meters squared. Now, volume is in meter cube. Volume is in meter cubed. But what we need now is to find work done and energy rather. Work done is energy too. So, energy or work done, according to this question, is, this one is measured in Newton meter. Now, how can we get Newton meter from Newton per meter square and meter cubed? Now, you see that if you do Newton over meter squared and you multiply this by meter cubed, now observe what happens. Meter squared goes here, leaving you with just meter, so we have Newton meter. So the only way to do this is pressure multiplied by volume. Okay? And then when we come to your question, you see that we have pressure and we have two values of volume. So initial volume, final volume. So what you will do in this case is to multiply the pressure by the change in volume. So we can then say solution. Our work done is pressure and change in volume. So basically what we have here is pressure into V2 minus V1. So the pressure here is 10 to the power of 5. Now we multiply that by the difference in the volume. This is 1.2 minus 0.6. Now this would give us 10 to the power of 5 multiplied by 0.6, since the difference here is 0.6. And if we write this in standard form, it will be 6 times 10 to the power of 4. Because this is moving this way, which is negative 1. And 5 minus 1 will give you 4. And we leave, of course, with the unit of this is joules. So 6 times 10 to the power of 4 joules. And since we have options here, we then pick the one that is correct, and that is option D. This question says, if the force and velocity on a system are each reduced simultaneously by half, the power of the system is... Now we have options such as doubled, reduced to a quarter, reduced by half, or constant. Now you can take a moment and try to find out which of these options is correct. Now you compare what you get to what we get at the end of this video and then see how well you did. And don't forget to leave us a comment if you are correct. Now, in order to get the answer to this, what I expect is that you should be able to derive what happens when you reduce force and velocity by half. Now, take note that the power of a system is a product of the force and velocity. So here's the solution. Now, the original power of the system is the force multiplied by velocity. Let's call that initial power, P1. Now, when you reduce force and velocity, we get a power P2, which will now be half of the initial force multiplied by half of the initial velocity. Now, what this would give you is 1 times 1, 1, 2 times 2, 4. 1 over 4 FV. Now, to linearize this, you cross multiply, you now have 4P2 equals 1 times F and V will give you FV. Now, but FV is P1. FV equals P1. So, 4P2 equals P1. Now, what this implies is that the new power of the system is the initial power divided by 4. That means it has to be reduced to a quarter of the initial power, which means option B. Now, just like the questions we've solved so far, there are still many more on work, energy, and power that you will find. So we advise that you solve as many as you can. And if you come across anyone that is challenging, you can always put it in the comment section of any of our videos, and we'll be sure to solve those questions with you. So please keep your comments coming. And please, if you're not subscribed to the channel, please ensure that you hit the subscribe button and also the notification bell icon so that you get alerted every time we put out a new content. And be sure to share the video as well so that you can help us reach many other students that need helpful videos like this. So with what we've done so far, I believe that you can solve many questions now on work, energy, and power. I'll be seeing you in the next video where we continue in our study for the SS1 first term curriculum. Thank you for watching the video. I'll see you on the next one. Bye.